So in this tech tip video, we want to go over talking about how to set the vertical tool height of tooling on the lathe. And we can now do that a lot more easily with this tool height setting gauge. So we'll go over how to use that, and we can talk about other aspects of this tool, like how to calibrate and those details. But first, it kind of is going to be helpful to kind of go back to kind of the start of things and talk about why vertical tool height is important on the lathe. So before we can do that, we kind of need to talk about geometry of lathe cutting tools. So typically on a lathe cutting tool, we're going to have some type of angle here at the front part of the tool, which is basically a clearance angle that ensures that when the tool is engaging with the material, that we're reducing the amount of area that's in contact with the material so that we don't effectively have like a bulldozing action. So if we think about like an ideal cutting scenario, if we're looking kind of down the axial view of our workpiece, so here's our spinning workpiece, and then here's our cutting tool that's going to come in radially from the side. So here's our clearance angle, right? So if we had an imaginary straight line here, when this tool contacts with the material, all of this section of the tool would potentially be rubbing instead of actually would be rubbing or bulldozing into the material versus, being functional and cutting. So by having a clearance angle here, we prevent, over-engagement of the tool effectively. But in a perfect world, the top edge of the cutting tool is going to be at the same level as the center of rotation of the workpiece. So that way, when the material, when the part is spinning and the material engages with the tool, it engages right here at the top of the tool, and then we kind of proceed to have our chip formation process. So in order to do that, there's lots of different methods that we can do in order to figure out whether or not we can get the tool in height, but we'll talk about those in a minute. But they're all going to be kind of iterative, and they're all going to be kind of a little fiddly. So using a gauge that kind of gives you more direct measurement of that height is going to be it's going to be faster, and it's going to be a little bit more effective. But in a perfect world, we're on center. But if we can't be on center, where's it better to be? Do we want to be above or do we want to be below? Well, really, if we can't be on center, we want to be below, and then we want to kind of approach to the center line. And the reason for that is, if we look at that scenario where the top of the tool is below the center line of rotation, as the material is turning and as the tool engages, we're still going to engage on that top surface. So we may not have, perfect mechanics of forming a chip and all of that, but we'll still be kind of semi-properly engaging the material on top of the tool. But that problem ends up being is that once we approach the center point, we're going to miss, some radial distance to the center on the part, and that manifests as a little pip. And that's what we talk about when we talk about the pip test of doing like a facing cut. You can drag your fingernail across the face of a part and see if there's a little, stub of material that's proud. That indicates that we're below center line of rotation. But if we look at the other scenario, where we look at the tooltip being above the center line of rotation, we have less ideal mechanics basically involved here. So as the material is turning and then we engage with the tool, well, we can see that the tool is going to be kind of above that tangency point of engaging with the material. And instead of engaging the material on top of the cutting edge, we're going to effectively kind of have more engagement starting here and a little bit more of like a snowplower or bulldozer action happening before we can engage on top of the cutting edge. So that's kind of like the thought process and the reasons why it's important to be on center line of the cutting tool. So the tool height gauge is pretty simple in design. So it basically uses a dowel pin. So the reason I'm using a dowel pin, one, it's durable, but two, it has good dimensional, like the dimensionality of it is good, so the diameter is going to be consistent across the entire thing. But also, kind of more importantly for our purposes, we have good geometry. So we have a good circle or good circularity because of the way that these are manufactured, being like precision ground. So on top of, or mounted on that is the gauge, which is basically set in a bearing that allows it to rotate. And then by using that rotation, we're kind of playing off of the idea of using like a pivot point and some indicating like shim stock or something like that to figure out where the tooltip is engaging. But instead, we're going to directly read off of the tooltip. And then this precision glass vial or glass level will basically allow us to figure out whether or not we're high or low. So it's a pretty simple system. And all that's involved is taking our gauge and then chucking it in the chuck. So this is a 1/4-inch dowel pin, so it lends itself pretty readily usable in, you know, a 3-jaw chuck, a 4-jaw chuck, or a collet system for kind of flexibility and ease of setup purposes. So once we have our gauge mounted in the chuck, we basically lift out of the way so that we clear the tool. We bring the tool in to approach, and then we're going to set the gauge on top of the tool, and then we're going to basically kind of move the tool around radially to where we're kind of resting on that tip, right? Because if we bring the tool all the way in and then we rest the tool down, we're actually indicating off of the backside of the rake of the tool, which is not really what we want to indicate off of, or it's not the measurement that we want to look at. We want to look at the tip of the tool. So you can basically look at the vial and kind of figure out whether or not you're lowering or raising and figure out where the high point is effectively, and then that's kind of be where you're going to want to look at your indication. So in this case, if we were to look at the vial, we can see that the vial is indicating that this tool is a little bit too high at the moment. So if we go back to remember how these quick change tool posts work, the height of the tool is set by this kind of thumb washer or this thumb screw washer, and then this lock nut on top basically just prevents that from being able to turn. So you may have to loosen the lock nut, and then you'll basically rotate the thumb washer or the thumb screw washer to set the height of it, and you'll re-engage the lock nut. Now that said, you will have to chase this a little bit, right? Because as we play with the mechanical system of the threads here, as we tighten, we'll actually cause this to rotate a little bit. So we may have to have a couple of different iterations on this to make that work, but in general, it's going to be a lot quicker than trying to do series of facing cuts or to use, you know, like a piece of shim stock and do like a pivot test, because those are not really directly reading off of that tool height. So again, like I said, this is indicating that we are too high, so that means that I would need to lower the tool. So if we zoom in closer, looking at our height gauge and looking at the tool, we can see that this is reading that the tool is a little bit too high. So if you're ever unclear in terms of what direction is indicating what level of the tool, you can always just by hand manipulate. So we can see that when the bubble in the vial moves towards you, the user, that indicates that the tool is high, right? Because we tip it back, we raise the gauge, which would be a higher tool, the bubble comes towards us. So this is indicating that we are a little bit too high. So we'll just break our lock nut on our tool holder, make sure that the quick change tool post is disengaged, and I'm going to take kind of small corrective actions and try to sneak into getting the tool on height. So notice how just engaging the quick change tool post really moves that vial. So that's something to be aware of, is that you're going to kind of have to make sure that all of the components are locked down before you take your final indication off of the gauge to figure out whether or not you're on height. So I'm going to shoot to be a little low, knowing that the quick change tool post seems to influence the tool to rise. So the process is a little bit finicky still, but we're at least working to a little bit more known point in space in terms of the height of the tool, instead of kind of chasing either cut tests with the pip at the end of the part or kind of indirectly inferring the tool height based off of the movement of some shim stock relative to the part or relative to the tool. So we're kind of constrained, I guess, in a way of what we're chasing. And in a perfect world, tool setup is done minimally. But in a shop like the generator, where people need to use tools on and off in different ways, having a tool that makes setup and re-verifying tools is going to make life a little bit easier. So you can see here, we're pretty much on level. So if we were to do a test cut now, I would expect that we'd be able to do that kind of facing cut, and we would get no indication that we're undercutting or that we're not cutting to the center of the part. And then I would expect that we're going to cut with good cutting mechanics so that we're not going to be above. So that's a quick primer on how to use the tool height gauge. And I forgot to mention this, but the way that we look at being able to calibrate or verify that the gauge is actually set up correctly to be able to indicate the tool correctly is we take the gauge off of the dowel pin, so just remove the kind of rubber washer O-ring, and then the gauge comes off, and then we want to put the gauge on the compound surface that the tool post is on. So we'll just basically set that up, make sure that we're leveled, that we're like not tipping the gauge. So make sure that the tool gauge is level, and then you'll look at the vial and you'll reference the vial, and if you need to, loosen the screw and then reposition the vial to make sure that the vial reads level.
Famous, number one, desirable. I do what I want when I want and how I want it.